My name is Gobind. I am a product manager at Google. I work on cloud networking and GKE networking. With me, I have my colleague, Colline. He's in the back getting suited up. I'll just introduce him. Colline is a senior engineer at Google, software engineer at Google. He thinks a lot about policy management and multi-cluster stuff. And you'll see some of that awesome stuff that him and his team have worked on today. The goal of this presentation here is to really give you an idea of three things, really, like how to think about security in a multi-cluster world. That's one. Second, you also want to think about how you can do high-resolution policy management using Kubernetes and Istio, which are at the heart of Anthos, which you've heard a bunch this week. And third, finally, you'll understand how to manage this across all your clusters without having to scale your security budget. So you can scale your security posture without having to really spend too much money on it. So that's where we're going with this. And since it's a Thursday afternoon, we understand that it's time to leave soon. So we'll try to keep it short and sweet and hopefully give you the most entertaining session that we can, because it's security, right? Who doesn't want to listen to security on a Thursday afternoon? All right, just a quick plug for Dory. If you have questions, please feel free to use our Dory app. It's how we do Q&A internally at Google. It works really well. We love it, so give it a shot. If you have questions, we'll be happy to get answers to you before or after the session. They'll save those questions, so we'll be sure to get. Oh, and so there's mics, so you can come up there. You've already seen the slide, but just this is actually more for me than it is for you. I practiced this presentation with CSP, and then they changed the name to Anthos like 2 days before that. So, so now if I say CSP, I mean Anthos. So yeah, it's all Anthos now. OK. We've got the housekeeping done, so let's get into the content. So the agenda for today, we'll figure out how Anthos puts a framework around network security and how we think about what security means in the multi-cluster world, and how defense in depth really applies to that concept, which is how we've figured out that security should work in the future. We'll see how the different layers of Anthos, so Kubernetes and Istio, specifically give you very high resolution policy management, which you can use to protect your clusters at every layer of the system. We'll see a demo where Ray will step on up and he'll show you how to do this very effectively and very quickly. You'll probably never go back to using stuff that you're using today. So I love it, personal bias, sorry. And then we'll talk about Anthos security monitoring, which is really important because once you've deployed your policies, you also want to see them working. So we'll talk about how to do that, and then we'll have some closing thoughts. Cool. Let's start with Anthos core values. So I don't know if you've seen these before already, but I just want to level set here. Modernizing in place is a key pillar for Anthos. What we're trying to do here is for you to be able to take advantage of latest cloud tech without having to leave the comfort of your home. Home in this case being on-prem, right? You don't have to move to GCP or whatever to take advantage of all the great tech like GKE and other things like we're working on. So you can try this on your own premises and at your own comfort level and try to migrate over if that makes sense for you at your own pace. That's the whole value proposition of Anthos. Another thing we really care about is automating policy at scale. And why do we do that? We've all owned or own multiple smart devices, and they all fall out of sync, and we've all seen that. It's a huge problem. And you can imagine if you start having multiple Kubernetes clusters or GKE clusters all across the planet, let's say, if they start falling out of sync, that's not a pleasant thought for anyone, and especially in security. So and we want to take that grunt work out of the system for you, and we want to do it for you. And that's where we'll go with this as well. We'll show you how that's done. And ultimately, we want to take all this towards a consistent experience. That's what really we're doing here. We want to build this consistent system so that you only have to build your tech once, and then you can deploy it anywhere. That's really important to us, and automation is a huge part of that because it'll help you be consistent, because obviously you don't have time to keep learning all the new tech as it comes out. You have other things to do as well. So we want to make sure that you get a consistent experience using Anthos. OK. Just a quick 10,000-foot view of what Anthos looks like at a top sort of surface. a couple of key things here. I know there's a few things going on, so I'll just quickly go over them. Anthos control plane is really your management plane, where you can do things like policy management, service management, and cluster management. The idea is that for you to be able to run on-prem or in cloud, GCP or AWS or whatever it is, you can run there, but you've only built this once, and you can manage it all centrally from a single pane of glass. And then the other more important thing, which is more relevant to this session, is thinking about security from the ground up. So when GKE and Istio came up, as projects, security was a core design principle for all of these technologies at every step of the way. So it has, it's a first-class citizen for security to be part of these layers, and that's what we really want to talk about in the next few slides in this session. Okay. Quick description of why this slide is here. So we all have been doing security for a long time, and it doesn't. We've been doing it for a very long time, ever since we started putting computers on the internet. But it's still a really hard problem, and the problem is as our security techniques evolve, attacks evolve, and then we're like, okay, it's the chicken and egg problem again. We were still chasing and trying to fix this. So what do? We can't build a one-size-fits-all solution. Every organization is different. Every company has different needs, and that's totally understandable. And the hard shell perimeter model, or I think it's also called the eggshell model, it doesn't work very well anymore, because we've seen examples in the past where infiltrators have been inside the company, and that's not going to work anymore. So we take microsegmentation at every layer very seriously, and that's why we think about security as a defense in depth model, also referred to as the onion model, which is why you see that picture there. And to relate that onion model to Anthos, we really think about Anthos in 3 different layers of infrastructure. We think of them starting at the bottom of the pyramid with nodes. We all know our VMs. We love our VMs. They're awesome. And we've also protected them in firewalls for an eternity at this point, so we're not going to talk about firewalls, right? And the next level up from nodes is pods, Kubernetes pods, which is somewhere in the middle of nodes and services. And then finally, at the top, we have Istio services, which is our new service mesh that we're talking about. So those are those 3 levels that we're imagining Anthos as, and we want to think about security at each of these layers to give you a very strong defense in depth security posture. It actually still says that the clusters are in California, Illinois, North Carolina, and Texas. So just imagine a United States map there. So I want to motivate the example here a little bit more, because we're really talking about multi-cluster now. We've done one cluster. We're now going out and deploying multiple clusters all around the country, the globe, what have you. And what we want to try to do is understand what sort of problems we get into when we start talking about security at this scale. So imagine a retail bank. I mean, this could be retail anything. A retail bank, it's running on Anthos. What that means is they've deployed 4 unique GKE on-prem clusters. So they're all independent standalone GKE clusters running on premises in the branch. And the idea there is that the bank has realized that real-time services for their customers is super important. So they've taken the step and they've adopted GKE on-prem. That's great. And they've deployed 4 for now. They've gone to California, Illinois, North Carolina, and Texas. So this is great. But now you're already asking the question, how do I keep these things in sync, right? Because you can change one thing on one cluster, and then suddenly all of your other clusters are out of sync, right? That's not all. Once that starts happening, you have fleet fragmentation, because your apps start diverging in versions. And the worst part of it all is that leads to all your development teams adopting a different workflow for production and deployment. And that is a security nightmare for every one of us. So we want to prevent that. Okay, just to motivate the example a bit more, I want to show you what they're running inside. It's a simplistic example. We've obviously curated the details for you to get the most out of the session. It could be a much more complex setup, but imagine each cluster is running 3 services primarily: account summary, products, and PII database. The idea here is that a teller could come to the home page and look up a customer's account summary by making a request, and the account summary can get access to PII database, but product service, or any other service for that matter, should not be able to get to the PII database under any circumstances. So that's our sort of setup for this problem, and we're going to work through this step by step to see how we can use all the layers of Anthos, namely Kubernetes and Istio, to protect this and get the posture that we want. Okay, network policy. How many of you have heard of network policy? Kubernetes network policy. Okay. Okay. Well, okay. Maybe like a fourth, maybe a third of the room. Maybe I don't know. Okay. So that's good. Why do we need it? Okay. So we have pods that I told you about earlier. Pods. When you deploy Kubernetes pods today in your system, by default they can talk to anything, right? This can be a good thing and a bad thing, depending on how you're looking at it. From a developer's point of view, it's awesome, because you can get access to whatever you want. From a security person's point of view, it's not cool, because you need to be able to lock it down and make sure that the surface area is protected. So keeping that in mind, we have this feature in Kubernetes. It's OSS. We fully support it in GCP and GKE. So you can think of it as a firewall for your pods of sorts. What it does is it cuts down any sort of restricted traffic out of the system, so your pods can never go out and do stuff that you don't want them to do. So that's the idea behind this. You can express rich ingress and egress rules using this API. You can actually write IP addresses and CIDR blocks if you choose to. I recommend not. You can do that, though. You can use Kubernetes labels, and you can also use Kubernetes namespaces. So that's awesome, because it's a first-class citizen. And finally, if you're already using namespaces in Kubernetes to support your workloads and keep them grouped and separated in some sense logically, you can use Kubernetes network policy really easily, as it is a namespace property. So it applies to all your pods within the namespace instantly. So that's really, really cool. All right. So let's bring it back to the example that we looked at earlier. We had our account summary service, we had products, and our mission was we don't want any other service except for account summary service to be able to talk to the PII database. So here I've set up a simple policy, a network policy object. It's missing a few details, but the key things are highlighted. What we're trying to do here is we're trying to select the PII database pods. Right? So I want to emphasize the fact here that we're selecting pods here. We're not talking about services just yet. We're talking about pods. We're still in the middle of VMs and services, so we're at pods. So we're selecting our PII database pods, and what we're doing is, the moment we implement the network policy selecting the PII database pods, all the traffic is cut from PII database. So the PII database pods cannot go out to the internet, cannot go out to other services or other pods. Other pods can't come to the PII database. It's a purely whitelist model. So a whitelist model means you have to explicitly now tell the system what traffic is allowed to come to PII database or go from the PII database. So the words we use for that is ingress and egress, which I'm sure all of you are very familiar with. So just to sort of summarize that comment, the moment you create a network policy object and you select all the PII database pods, all the communication, all network traffic is cut off from them immediately. Now you go take the next step and you say, okay, I want to allow ingress from account summary to PII database. So you say, okay, well, I'm going to select all the pods that are running account summary service, and I'm going to let them talk to PII database. That's great, and that actually solves our problem here. So we've talked about ingress, but I've left out the egress part just yet. So you can actually either mention the egress keyword here or leave it out completely, because as I mentioned earlier, by putting it under a policy, you've already cut traffic from it entirely, so it's a whitelist model. If you do not enable explicitly any egress sources, no traffic is leaving your pods, and you can be sure of that. All right, we're moving a level up now. So we've talked about our pods. That's great. We've secured them at a lower level of the infrastructure. That's fantastic. We've cut our surface area. We know for sure that some of the IP traffic we don't want to reach the pods is not reaching them. That's awesome. But now we have to start thinking about our services. So who here has already heard about HDS Security Policy? Almost the same fraction of people. Not the same people, same fraction of people. OK, so what we're going to try to do is just, actually, how many of you have heard of Istio and understand what Istio is almost? OK, good, good. I'll try to I came up with a cool analogy. I think it's cool. I'm biased. I'm sorry. I'll give you a cool analogy to how I understand Istio. So it's imagine you're a host at a birthday party with lots of children running around. These children are microservices, and you're trying to protect them from getting hurt, right? So if you can actually strap balloons and stuff across everybody, that would be great. But you can't. There's too many kids running around. You can't do that. So you can imagine Istio coming in and helping you there and saying, OK, I'm going to let you control all these microservices, because luckily, microservices are easier to control than kids are at a birthday party. But yeah, that's my analogy. You feel free to use it if you want to. But yeah, that's where we're going with this. So to control all your Istio microservices, you need to put security policies in place. What do we have here? So we, first of all, start with strongly authenticating all our services, as well as our users. So Istio by itself issues strong identities, strong non-mutable identities to each service that's running inside your mesh. So this is great because we'll talk about the next point here in a moment. But this is great because it's non-mutable identities. You don't have to lift a finger for this. Istio does it for you right off the bat. And users are also authenticated by the system, but the identity is not issued. We'll touch on that in more detail later. So let's keep going. OK. Encryption for everyone. So because we've authenticated everybody in the system, including users, including services, we can use that identity to encrypt and establish an MTLS channel between all your traffic within the mesh. So you can get service-to-service encryption for basically free without having to change anything. And context-based authorization. So we've done authentication, we've done encryption, but we also want to do authorization because we want to make sure that only certain parts of the system are accessible and certain parts are completely off access, because really access is really a non-binary thing. It's more of a spectrum. Some people have access to certain things, some people have access to other things. So we're going to look at how to do partial access as well. OK, going back to our example. So let's start with authentication. In this case, I've set up a simple example. Again, these are some of the most common examples I see when people have questions. So there's more details. If you keep reading more and more and more, you'll get very excited about security, as I do. But here I've taken a simple example of user authentication. What's happening here is we're using a policy object, Istio policy object here, and we're selecting the PII database service in this case, not pods. We've moved up a layer. So this is the PII database is the Istio service that we're targeting here. And we're selecting it under this policy object. And we're saying only let users who have JOT tokens issued by acme.com access this service. So JOT tokens, if people are familiar, they're a common OIDC protocol implementation. And a lot of times it could be Active Directory or Okta or any other provider like that. But Istio uses JOT for the time being. And in this case, you could provide a signed token from acme.com, and the system will let you through, which is great, because if it's coming from fakeme.com, it won't be allowed access. OK. Encryption in transit. So we've done identity. That's awesome. How do we take it from there to giving you encryption? Well, you don't have to do anything. The system does it for you. How does it do it? We have a little thing called Envoy sidecar proxy that's part of this Istio bundle. The Istio bundle installs the Envoy proxy in front of all of your microservices. And every time you have a service that wants to talk to another service, if you enable this policy, so in this case what we're doing is the PII database service is being targeted by this policy, and it's saying all my peers should use MTLS while talking to me. The curly brackets there, not specifying a service, means all services. So what this does is it forces all of the people or all of the services that are trying to talk to PII database ensure that they have MTLS enabled or encryption enabled. The one thing I didn't show here is it's called the destination rule. Ray will briefly touch upon that in his demo to show you how account summary can start talking to PII database using MTLS by setting a destination rule after this policy. Authorization. So We've done two things so far. We've prevented untrusted access to the system, and we've prevented man-in-the-middle attacks. But that's not sufficient. As I mentioned earlier, a lot of times your users have partial access to the system. They don't have full access to the system. So how do you go about doing that? So in our little example here, I want to allow tellers to only be able to read the PI database, but not write anything to the database. So what we're going to do here is we're going to set up a service role called PII viewer. And what that role is doing here is it's granting get permissions to the PII database. So the get would be the HTTP equivalent of read. And when you associate that service role with the service role binding, and in that service role binding, what you're specifying is that the access has to come from account summary, and it has to come from a group called tellers. So that group is actually coming from the JOT token that I mentioned earlier. These are details you can read about more if you wanted to, or I'm happy to answer questions afterwards if you have any. But the idea here is that you're very clearly specifying in your authorization policy what is allowed to access your PI database service and what is not. And only the tellers group can do a read here. So we've talked about several policies already. I kind of want to show a picture of how they all fit together and how they work in harmony, so to speak. This is the path we really want. We want a user at acme.com or a teller at acme.com to be able to access account summary and be able to get to PII database. So we lock down the access from PII database to the internet, and we lock down any other service, any other pods from being able to reach to the PII database. So we cut that out first, right? That was our first never policy object that we created. It locked down access from products to PII database. We also cut out access to internet. So PII database, if it had any faulty code or anything inadvertently tried to go to the internet, that's all cut out also. Then we went into authentication. We cut out access from fakeme.com and any other websites that might be issuing tokens and trying to access your system. We enabled encryption so that account summary and PI database are always talking on an encrypted channel so that none of your man-in-the-middle attacks can actually steal data from you. We also cut down the HTTP post request from user at acme.com. What we're trying to do here is very clearly draw a line between what's allowed from the tellers group and what's not. And if the teller got really clever here and tried to bypass the account summary, that would also be rejected. So the only path left in the system is this one. And that's what we just implemented with 3 simple policies. So I just want to just show you the power of this sort of fly-by-wire security system where you're doing everything based on policy. You're not configuring firewalls anymore. You're not configuring manual switches anymore. This is moving above a layer, and it's giving you a real fly-by-wire experience because you can do all this by setting a few policies, and all of the fabric will change according to your requirements to give you as high a microsegmentation as you could possibly imagine. Just to quickly distinguish between the two policies that we've talked about Kubernetes network policy, we've talked about HDS security policy. You might be asking why we have to use both. The real answer is they're both good at they're really good at different things. So Kubernetes network policy is really good at cutting down your attack surface area, while HDS security policy gives you fine-grained access control at the service level. So you need the umbrella and the raincoat to protect you from the rain. And now we have our demo. Please welcome Ray.
So hi, everyone. I'm Ray Colline. I'm a software engineer, and I work on Anthos config management. And so today what we want to do is take you through a demo which is going to show a lot of the concepts that Gobind just talked about in his presentation. And if you've installed Istio, it comes with an example application which looks a lot like the bank example that Gobind just said or talked about. So here we have a ratings app. You could think of this as the PII database. You have a reviews system, which you could think of as like the account summary, and then you have basically a product page at the front. And these 3 things then get requests, and then they're allowed to talk to these different backends. Now, I'm also going to be demoing Anthos Config Management as a way to deploy the book info app and show it on 2 different clusters at the same time. So the idea here is if you're running in 2 different availability zones or in 2 different regions, you can deploy this app using one set of edits into a Git repo, and then those will propagate off to each of the clusters. And if you wanted to do a progressive rollout, you could insert a cloud build pipeline, which basically each cluster gets its config, and then 10 minutes or an hour later, it could go ahead and get the other one. And you could stick a canary analysis service or something else in between. So with that said, let's go through and kind of show you the setup here. So we have 2 clusters. One is in US Central 1, and one is in US East 4. And these are just really simple clusters. You'll see currently on the URL here that there's nothing there, and on here there's nothing there. And when we switch over, I'll go over here. So what we'll see here is we have, in this window, is looking at all the pods for cluster 1. Here we're looking at all the pods for cluster 2. And here we're looking at cluster 2's service role, so these are policies. And this here is my Git repo, local Git repo, where I'm going to be making my changes and pushing them. Now this gets sent up to GitHub. And GitHub is right here, which you can see also, if I refresh it, has nothing in it, right? It is just a blank thing with system, which is the default way. So these clusters, I've installed the Istio operator, and I've installed the Anthos config management operator, and then I configured the Anthos config operator as such. Right? So what we can see here is when we look at cluster 1, you'll see that it's just a regular YAML to configure config management, and we give it a cluster name. So amazingly, in Kubernetes, there's no cluster identity built in. So we actually give each cluster a name so we can refer to it for purposes of being able to target policies at a given cluster. We then tell it where to go. So I'm telling it, hey, go to GitHub and go to this route here. And then I could tell it which branch. So I'm saying go to master. And if you wanted to go to Canary, you could go to Canary. You could end up creating a branch and using the git merge functionality to push things along. At this point, I'm telling it to use SSH. We support SSH and Git cookies. And I'm saying, hey, use this route as the policy directory. And that means you can use one repo and have different environments in one repo if you want, or you could have different repos. It's up to each person or environment. So anyways, I've installed that on 2 clusters. And so let's go. At this point, what I'm going to do is I'm going to deploy the book info app, but I'm going to deploy it insecurely. So everything is plain text. There's no security rules, and everything can talk to each other. All right? And so what you'll see here is I've created a new namespaces directory. I've created a book info namespace. I've created the namespace YAML, which is the same one you would kubectl apply. I've created a book info, which has a set of services and a set of deployments, which map to the 4 different services that are said, and a book info gateway, which exposes it to the outside of my cluster. So at this point, I'm going to go ahead and add this. Initial deployment, and then I'm going to git push. Okay. So that gets pushed up, and then we can do what we'll notice on the right-hand side is these pods will start creating, and there we go. So on cluster 2 picked it up, and it's going ahead and deploying the app as we review this. And then we have that on cluster 1. So what's going on in the background is there's an agent running on each cluster that's looking at that GitHub repo I showed you earlier, and it senses that there's a new change in there, and it goes ahead and pulls down that stuff, and kubectl applies everything in that repo automatically. Okay, so when we go into namespaces, right, you'll see here that these are just everyday standard files, right? So here we have a service, here we have a deployment, right? Service, deployment, ports, etc. Okay, cool. So with that said, what we should see here is our bookstore app. And we have the details, which is one service, and we have the product page, which is this overall page, and we have the book reviews, which is comprised of 2 services. One is the review, and one is the rating. And you'll notice that in the book info example, there's 3 versions of the ratings, And if I refresh this, you'll see that we are doing round robin. Network's not as fast here. And these should change over time, as in this is a different version, and they're changing. So this is showing us that Istio routing. And what you can do with Istio, which is also cool, which we didn't, or Gobind didn't cover, is there's also this idea of routing. And so you can run multiple versions at the same time, and you can do traffic shaping and traffic spreading and roll out 5%, 10%, et cetera, to new versions to make sure that things are happening, in addition to all the security benefits. Okay, so now that we have this deployed, it's insecure, what we want to do is we want to layer encryption on top of this. So we want all the pieces here, instead of being plain text, we want them to actually have the nice little barrel of encryption around them. So let's figure out how to do that. So I go back here, and what you'll notice is, in the current images, so I've gotten all the pods that are there. These are the images that are running, which is just the book info software, okay? As we stated with earlier, is that Istio has a sidecar proxy that runs as a container. And that gets injected when you run your pods, and that's where the proxy happens. And then the way that the Docker networking stack gets set up is we only allow those pods to talk to the proxy and nothing else. So now all ingress and egress must transit through the proxy, and that gives Istio that gives you the security guarantees that Istio gives you. So let's do that. So I enable MTLS on each. You'll see here that I ended up with some extra files, which I'll talk about in a minute here. And let's go ahead and add some. Okay, so we're adding some MTLS. We're pushing that up. Let's go look what actually happened here, okay? When we go to book info and we look now at the namespace, you'll see here that we have this comment called Istio injection enabled, right? And I'll do this because syntax highlighting is fun, right? So we have Istio injection enabled. And what this says is anytime you create a pod, go ahead and automatically add the Istio sidecar to that pod, the container, the Istio proxy container to that pod, and wire it up so that they only can talk through the proxy. Cool. Now that we have that enabled, oh, and we'll talk about destination rules too, which are fun. So with destination rules, what we're saying here is, hey, if I'm going to go ahead and talk to the product page, I'm going to use Istio mutual. And that means that when I talk outbound to egress, I'm going to use, and I want to talk to the review service, I'm going to use MTLS. And this is set for all the things, ratings, reviews, details. And this says, hey, on those arrows, go ahead and encrypt those with MTLS when I talk. And then the other thing that we did here is at the cluster level, when I go to cluster, I have a mesh policy now. Now within CSP config management, when you have put things in the cluster directory, that gets pushed to the root level of each cluster that's being managed. And so now cluster 1 and cluster 2 both have this mesh policy that says the following. It sets a default policy and it says MTLS. So it says any pods in any namespace must use MTLS to be talked to. And so that helps you as an administrator guarantee that you're using MTLS. Okay. Now what we're going to notice here is because we've changed the makeup of the pods, that doesn't reconcile automatically. And when we show the current images, we still have the Istio book info. So we need to restart the pods. And so I'm going to show you a feature of Anthos config management, which my coworker facetiously named insistent reconciliation. And that means that whatever the state that's in the repo, we guarantee that we make the cluster that state. So if I destroy the deployments, which I defined in the repo, the Anthos config manager will automatically recreate them. So I'm going to go ahead and kill those deployments. And you'll see here that they've gotten all deleted. You'll see that you'll have a bunch terminating. And now you have a bunch initializing at the same time. And so that happened because the Anthos config management wants the cluster to be in the state of the repo so we can have that guarantee. So at this point, what I'm going to do is show the current images. And what you're going to see here is 3 of them have now picked up the Istio proxy. And then you have the 3 that are terminating, which will go away soon. So now we have Istio proxy sitting in front of our existing pods. We have told the system to use MTLS. We have encryption across all setups. So at this point, what I should see is, when I refresh this, assuming everything is speedy, is the book app should be working, as is, which it looks like it is, sweet. Except now, everything is talking encrypted between all of these different points. Okay, cool. So next step, now that we've got encryption, what we want is the ability to lock things down, right? And we want to say, you know what? It's great that you have encryption. It's great that you have authentication, but now let's put some authorization into the mix. And we're going to start by just turning on authorization, but setting no policy, so it's deny by default. So we're going to go ahead and enable service RBAC. And you'll see here that we got a cluster RBAC. So let's go ahead and push that. Git commit-m, add RBAC, and then git push. So when that goes ahead and push, let's go look at that cluster RBAC policy and see what it says. So here we go. We have a cluster RBAC config. We have applied at the name default, so it's the root one for all the whole cluster, and it's saying for this namespace, right, please enforce. And enforce is deny by default, which means you have to explicitly list the RBAC service binding in order for things to talk to services. And so now this forces all of the application writers on your clusters to explicitly detail their dependencies. So in this case, we're going to want to be able to, each one of these things is going to require a rule. So product page can talk to reviews, and product page can talk to details, and reviews can talk to ratings. Okay, so we push that. We're saying it's enforced. What I would expect to happen here, now that we have that, is the app should break. And it has. And you'll see here that on both clusters, I get RBAC access denied. I tried to hit the product page. When I hit there, it said there's RBAC. There's no RBAC authorization allowing my user to get the product page, so it said go away. Great. So with that said, let's go ahead and add a partial rule to show how you can add authorization on a piecemeal basis. Okay, so we're going to do adding a RBAC policy. So you'll see here that we got a namespace policy file. We're going to go ahead and add that. Partial policy, and git push. Okay, so while that's going on, and again, all of this is happening through Anthos config management. I'm not running kubectl at all. It's all happening behind the scenes. When I go into the namespace, there's extra credit if people can realize that a couple things here about the security aspects of these policies and of the page. I'll see if anyone identified them at the end and go from there. So when we look at this namespace policy, you'll see here that I have a service viewer role. And what I'm saying is that all services, so basically matching any URL, right? Any method, get, and I'm saying allow these apps, product page and details, to talk to each other, okay? So I'm allowing the product page to talk, and I'm allowing people to talk to the product page, but the details are being able to be talked to by the product page, right? But notice what's missing here, ratings and reviews. And then down here, I have a role binding, which binds both the Istio system namespace, so it can get telemetry, right? And the book info namespace, which says, hey, things running in book info are allowed to be given this role as long as they have the constraints of the destination labels being product and details. Okay, so what we should notice now is a partially working app on both clusters, and that's what we have. We have the details, we have the product page, but we have no product reviews. There's been an error because it's got an RBAC denied, which will return as a 403. Okay, cool, so that's great. We've been able to partially do that. Let's add the full, and by the way, just to show you that this is all real, we have all these things within the Git repo, GitHub repo. Okay, so we're gonna go ahead and add the full service RBAC policy. And from there, we're getting, okay, so that's pushing. You notice how here we have a service viewer policy that just got pushed earlier. With that said, let's look at our namespace policy now. You'll see that we've added reviews and we've added ratings, okay? So at this point, everything is allowed to talk, right? We've enabled that. And so let's write that out. Cool. That's been pushed earlier. We should notice that the app starts working, and there it is, right? And doing the right thing through that. So great. We've just now gone back through. We've started with an empty cluster, just with Istio, and just with Anthos config management. We deployed the book info app insecurely. We layered on MTLS. We added cluster RBAC policy saying deny by default. We layered on a couple of different policies to have the app be able to talk to each other. And at this point, we have a fully kind of enabled RBAC Istio application that has been working from the beginning, from the insecure state to adding and layering on Istio, and I never changed a line of code in the Istio book info app. And to finish it off, I'm going to go ahead and remove everything. So that takes my repo back to normal. And then I'm just going to push this. So git add-a, git commit -m, kill it all, and then I'm going to push that. Okay? And as a final thing, if I actually go up here, what we will see is all of these things will go to terminating. They will remove the clusters, because if they're not in Anthos config management, we go ahead and we'll take them out of the clusters. That's one of the things that we guarantee. Again, we want the state of the clusters to match the state of the repo. And so with that, that's kind of our demo of Anthos config management and of Istio. Thank you, everyone. So.
Can we switch back to the slides, please? All right. Thanks, Ray. Thanks for that awesome demo. So originally, I said that your workflow might change. That's actually what I was referring to. Instead of using kubectl, you'll start doing git push everywhere. It's going to be awesome. So thank you for that. So we've put all of this together. We actually looked at this diagram here. Go back. Yeah. So Ray helped us see some of the core pieces of this picture just from the power of git push, which is great. You can do this across all your clusters. It'll give you a lot of peace of mind, because you'll be sure that all your clusters are running exactly the posture that you want. So going forward, so we've talked about how to deploy these policies, how to construct these policies, but there's one more piece of the puzzle, which is how do you keep an eye on everything? And that's where GCP console and Anthos really brings it all together for you as an ecosystem. You can connect all your GKE clusters or Anthos clusters to GCP console, and you can see them all in one place. You can see all the details related to that, any of your clusters, wherever they're running. Again, it could be on-prem, it could be GCP, it could be AWS. All you have to do is log into those clusters from GCP's console, and you will be able to see all the relevant details of the control plane in your GCP console. And as well, that goes for Stackdriver. So Stackdriver is our logging tool. You can use a Stackdriver to pull all the logs from your different clusters that you're running across the planet and bring them to Stackdriver for analysis. You could push them through to BigQuery if you wanted to. You could also use other tools if you're familiar with, if you prefer Prometheus and Grafana for graphing them. That's also great. And if you wanted to use Splunk or Elastic, all of that is supported as well. All right, well, we're close to the finish line. So really the three things that we started with here were, one, we wanted to give you a defense in-depth experience using this fly-by-wire concept of policy-based security. That's really what Anthos is all about. We talked in depth about very high-resolution security that you can get using Istio and Kubernetes policies. And finally, we looked at Anthos config management as a way to do GitOps and put your infrastructure as code, really as a workflow for CI/CD pipelines. So you can actually take all of your security posture and replicate it across as many clusters as you'd like in an instant. Well, one final call out to all the other security things that you have to think about as a network administrator. So we've been talking about Anthos clusters in in very high detail. But outside the cluster, there's a lot of other stuff happening too. So you have to think about things like your other infrastructure pieces. You have to think about DDoS attacks. You have to think about exfiltration. You have to think about secure access to your nodes. So I highly encourage you to look at all the other tools that GCP provides for you to ensure that you have a security posture that is comfortable for you. There's some related sessions. I know this is towards the end of the conference, but they'll all be available on YouTube. So please check them out. They're highly related to the content that we've covered. And the rest of them are offered here below at that link. With that, I'd like to thank you for your time. I appreciate you guys staying back on a Thursday afternoon. Thank you for coming here, and thank you for attending next.